Hey, what's going on? Advanced Math Day. So, our book mostly covers the high school standards, for Math 1. So, some of the eighth grade standards just didn't get really covered in our book. And since you guys are about to take the state test, I figured, hey, we could take a couple days and cover one of the major standards that we haven't gotten to, which is volume. So pretty easy. We're going to go through all the volume formulas today, and we're going to really focus on why they work, so that when you get to any particular problem, you don't necessarily need to memorize the formula. You can understand why the formulas work the way they do, and kind of develop the formula as you go. Anyways, here we go. So first of all, we've got length, we've got area, we've got volume. So there's major differences in the three. When we're talking about length, we're talking about one dimension. We're going simply from one point to another point, and let's say that this was, I don't know, 6 centimeters. The units are in centimeters to the first power because we're only talking about one dimension here when we're talking about length. So our units for length will always just be to the first power. When we get over here, now we're talking about area. Area, the units are squared because we have two dimensions. The area usually has a length and it has a width to it. So let's say that this length was, 2 centimeters, and this one was, 5. So when we talk about area, you probably before have said, hey, it's length times width. And yeah, that's what it is, to calculate it. But when we're saying that it's units squared, there's a very specific reason why we called the second power the square. Because we are literally counting how many squares fit in this, how many unit squares. So in this case, it would be 1 centimeter by 1 centimeter squares. So if I broke this shape up, let's go about here. 1, 2, I messed that up. 1, 2, 3. Okay, let's say this is 4 centimeters. All right, so let's say that's 4 centimeters. So I've broken it up. I've got 1, 2 centimeters here, 1, 2, 3, 4 centimeters here. Now we would normally say, oh, this is just length times width. It's 2 times 4. Well, the reason why it's length times width is because we're counting squares. Inside of this shape, we literally have 1, 2, 3, 4, 5, 6, 7, 8 squares. So with area, we're counting how many squares will fit into the shape. So when we say it's units squared, we're literally talking about squares. How many 1 by 1 unit squares are going to fit into the shape? Because we're talking about two dimensions, length times width. So area is always talking about how many squares fit in a shape. Volume is to the third power. You know what we call the third power, right? We call it cubed. We don't call it cubed for any random reason. We call it cubed because we're literally counting how many cubes fit in the shape. Now let's make this particular prism a cube where we're going to have I'm going to say this just to make this easy on myself to draw. I'm going to say this is 2 centimeters, this is 2 centimeters, and this one is 2 centimeters. So what we could do, let's see if I can break this up nicely. Let's say about there's halfway. That looks good to me. All right, so let's try to make this look a little three-dimensional like. So when we're doing the volume, like I said, we're talking about literal cubes inside of our shape. missed that one. That's all right. So here's the bottom of our shape. So in the volume formula, the general volume formula is we count how many cubes will fit in the base of our shape. This is the base of our shape. Okay, so inside that base of the shape, can you see it? There's going to be 4 cubes that fit inside the base of that shape. Not my best drawing ever, but you get the point. There are 4 cubes that can fit in the base of this shape. And then from here, we fill up the shape with the height of the shape. So I've got 4 cubes that fit on the bottom, and then the height tells us how many times we're going to stack those 4 cubes that are on the bottom. We're going to stack them twice. So yes, the formula, if you've done this before, is 2 times 2 times 2, length times width times height. But the reason why the formula works is because we're taking the area of the base, and then we use the height to stack that base on top of each other, one after another. We just keep on stacking it. And that's what the volume is tracking how many cubes we can fit inside of our shape. So the general volume formula is big B times H, where B is the area of the base. So in this case, this is 2 times 2, 4. And then we multiply it by the height of the prism, where we're going to stack those areas on top of each other to create cubes that are stacked on top of each other. So we're always going to take the area of the base and then stack it with the height using this height over here. And this general formula can be used with any shape that you can find. If you can find out what the area of the base is, you can find that area and then stack it with the height. Now, height does not necessarily mean up and down. In this particular problem, I did make the height up and down. The height is defined as what is perpendicular to the, or not perpendicular, it's what is parallel. See here that these heights over here, they're all parallel to each other. And we have a base on the bottom and a base on the top. So this base on the bottom is the same as this base on the top. The height are the parallel lines that connect the 2 bases together. That's in a prism. So in a prism, we have 2 identical bases connected by parallel lines. The parallel lines are the height. Now on this same problem, I could have said that the side over here, that this was the base. And then I would have had an identical base on this side. And then this would have become the height because these 4 sides are all parallel to each other. So in a rectangular prism or a cube like this one, the height doesn't necessarily have to mean going up and down. The height can go side to side, whatever. The height is just defined as the lines that connect the 2 identical bases. So the height is always going to be the lines connecting the 2 identical bases. Okay, so there's a prism. Now prisms, I could have made my base a triangle. So I could have made a triangle base. Well, let's see what that would look like. Okay, so I'm going to do it like this. I'm going to lay it on its side. So here's a triangle. And this is going to go back. Here's a triangular prism. I've got a base in the front this time. And back here you can't see it, so I'll make it as a dotted line. I've got a base in the back over here. In this case, the heights would be the 3 lines that are connecting those two identical bases. Okay, so there's my triangular prism. I've got a triangle in the front here. I've got a triangle in the back there, and then I've got these three parallel lines connecting those two. So we would still use the base area times the height. The height would just be these three lines. And then since it's a triangle, the area would be 1/2 base times height. So you could have anything for a prism. You could have a hexagonal prism where the base and the height are hexagons. A trapezoidal prism. So you would just find the area of whatever base you have. Mostly it'll be a rectangle, but you could have triangles and stuff like that. And then just multiply to the height. And the height has to be the parallel sections that are connecting those two bases together. All right, so there's prism. Next, here we've got a cylinder. Now, we're still going to basically use the formula volume equals base area times the height. What is the shape of the base in this one? The shape of the base is a circle. So I've got a circle down here, and I've got an identical circle over here. I can tell that this is the height right there because they are parallel to each other. They're the parts that are connecting the two bases together. So if my formula is volume equals base area times the height, and my base is a circle, how do we find the base area of a circle? Tell the person next to you right now. Like with your mouth words and stuff. Tell them. Okay, hopefully you told them. So, if you remember, the area of a circle is pi r squared. So what's the actual formula for a cylinder? Well, the general formula is base area times the height. The specific formula would be pi r squared times the height of the cylinder. It's still, this is my base area, and then I would fill it up with the height. I'd find my area of the base, and then the height would fill up the object, and we'd just start stacking those areas on top of each other. And now we get to a cone. So a cone is a little bit weird because it actually has two heights in it. So a cone does have a base area down here that is a circle. But unlike the cylinder over here, we don't have another circle on top. Instead, these sides are meeting at an exact point. So basically, this cone could fit inside of a cylinder. The cylinder would have gone straight up, whereas in a cone, instead of going straight up, we just go over here. So I've got two heights now. This one is called the slant height. It says L. Usually it's a cursive L, like that. But L means lateral height. That's another word for it. But that's not the height that we're allowed to use in our formula, and here's why. The height is not perpendicular to the base. So we can't use this height in our formula because it's not the actual height. The actual height will be where it's perpendicular to the base. So a lot of times your height is going to be inside the shape. So this is the actual height that we would use in our formula. The lateral height is not used in the volume formula. It's used in the surface area formula, but that's a whole nother thing. So we've got a radius and a height here. We're still going to use pi r squared times the height, but if this fits in a cylinder, the cone has lost some of its volume by coming to a point instead of going straight up, right? Because like if we come to a point instead of going straight up, we lose quite a bit of our volume. So how much volume do you think that we lose? Tell the person next to you. use your mouth sounds, whatever. How much volume have we lost by going to a point instead of going straight up? Tell the person, just make a guess. Tell the person next to you, what do you think? A lot of you probably guessed 1/2. It's actually not right. We lose 2/3 of the volume anytime with any shape. If we come to a point, instead of going straight up, we will lose 2/3 of our volume. That works for like even pyramids. Like if on this previous problem up here, if I would have created a pyramid out of this, where all these sides came to this point here, we would have lost 2/3 of our shape. We would have only had 1/3 of our volume left by staying inside this pyramid. So anytime your shape, instead of going straight up, goes to a point, you lose 2/3 of your shape, which means your volume only keeps 1/3 of its shape. So in a cone, the formula is the same as a cylinder because our base is a circle, so we use our base area of pi r squared. We've got our height. Our height is the height inside, not the slant height. And then we have to add to it that it's only 1/3 of this shape. So our formula for a cone would be the base area of pi r squared, the height that's inside the shape, but then 1/3 of it. Because when you come to a point, you lose 2/3 of your volume. So if I had a cylinder and a cone that had the exact same radius and the exact same height, the cone would always be 1/3 the volume of that cylinder every single time. Now, let's say that you were given the slant height and not the height. What could you do? Well, look at the shape here. It's perpendicular, radius here, height here. Does anybody see how we would find out what our actual height would be? If we know the slant height and we know the radius, can you figure out how we'd find the height? Yeah, it's a right triangle right there. We can use the Pythagorean theorem. R squared plus H squared equals L squared. So we can always use that to find missing sections if we're working with a cone. The radius squared plus the height squared will always use the lateral height squared or the slant height squared. Same thing, if they give you the height and the lateral height, you can still find the radius by using the Pythagorean theorem over here. Whew. All right, we have gone through 3 formulas so far. This is 3 lessons in other classes. So we've done it in, I don't know, what, 15 minutes or so? Yeah, something like that. All right, last 2 shapes. A sphere and a hemisphere. Now, this is kind of a weird shape. So in a sphere, if I asked you where the base area would be for a sphere, a lot of you would say it's the circle inside the shape. And that's actually not where the base area is. The base of a sphere is the entire outside section of the sphere. That whole outside section, that is your base. Okay, what am I going to do with that? I don't know. If you've ever been destructive before, looking at some of you guys, seen all the paper you tear up and leave on the floor. So if you're a destructive personality, you might have taken apart a baseball before. Now, it's not exact when you take apart a baseball, but you can see it. If you take apart a baseball is formed by 2 pieces of fabric that are kind of crossed over each other and stitched together. I'm trying to make them look about as good as I can. Okay, so these pieces of fabric kind of look like this. And then they're kind of stitched together, put together, and then they form a ball. But if you really look at it, you can see what's going on here. In these 2 pieces of fabric, there's a circle right here. There's a circle right here. There's a circle right here. and then there's a final circle right here. All this extra fabric is just to connect everything together. So the outside of a sphere has 1, 2, 3, 4 circles. Any sphere has 4 circles. So if we're doing volume equals base area times the height, the base area, the outside of this, is 4 circles. That is 4 pi r squareds. That's the base area. What about the height? Remember, the height has to be perpendicular to the base. Now this is circular, so perpendicular to the base would go here. But what if I go from here? It would go to there. What if I go from here? Perpendicular would go here. What if I went from here? Perpendicular would go there. What if I went from here? Perpendicular would go here. All of the heights on the outside all point towards the center. So if you're going from the side to the center, isn't that just the radius? Yes, it is. So the height of a sphere is the radius. So we've got 4 pi r squared times the radius. But wait, there's more. What did we just get done saying when the heights go and meet at a point instead of being parallel to each other? That's what's happening here. All these heights are meeting at a point like the cone. Remember what I said about the volume? Anytime the volume meets at one point, we lose 2/3 of our shape. So I can only have 1/3 of this volume. There's my volume formula for a sphere. 1/3 of 4 pi r squared times the radius, which is the height. If we simplify this, 1/3 times 4 is 4/3. And then pi. And then r squared times r is r to the third. There's the formula for a sphere. 4/3 of pi r cubed. Not squared, cubed. Because we've got the r squared from the base area, and r is also the height. So our formula for a sphere would be 4/3 pi r cubed. A hemisphere is half of a sphere. What's half of 4/3? Think about it. Hopefully you said 2/3. 2/3 pi r cubed. There is the formula for a hemisphere. Half of 4/3 is 2/3, so the volume of a hemisphere would be 2/3 pi r cubed. All right, there's the 5 formulas you need. The general formula is base area times the height. You'll mostly use these for prisms. Then you have the specific formulas that use the general formula. Cylinder, pi r squared times the height. Cone, 1/3 pi r squared times the height. Sphere, 4/3 pi r cubed. Hemisphere, 2/3 pi r cubed. All right, flip over your paper. We got some practice problems to do. If you're watching from home or I'm absent or something and the sub is showing this, at this point, you're going to try out these problems. The first 3 are prisms. So you're going to find the base area and then multiply by the height. The next 2, cylinders. The next 2, cones. The next, sphere, hemisphere. And then some word problems down here. Try those out. If you're at home, you can pause this now, or this is being shown to one of my classes or something. For some reason, I'm not here. We can pause this at this point, try all these problems out, and then I will solve them and show you what I got as answers. All right, pause it. Pause it now. How about now? How about now? All right, I'm going to show the answers in just a second. Oh, okay, so I just remembered something. I forgot to explain what leave your answers in terms of pi means. So remember, pi is an irrational number. It goes forever. It's 3.14159, blah, 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 blah. It keeps on going. So when it says leave answers in terms of pi, that means give the exact answer without rounding. So if you are using an irrational number, that number can't be written down unless you use a symbol for that number. So like the symbol pi. So let's say if I've got an area that is 9 pi, which means 9 times pi. So when it says leave your answers in terms of pi, that just means leave your answer as 9 times pi, or 9 pi. All right, I've already finished the first one if you haven't gotten there. There's my base area is 9.12. I decided the bottom was my base, and then I multiplied it with the height of 2.2. There's my base area. All right, so there you go. If you didn't understand what in terms of pi meant, that's what it means. So just leave your answer with pi in the answer. All right, now I'm going to pause again. All right, pausing now. How about now? All right, I've worked them all out here for you. So we already did that one. We got a base area of 4.8 times 1.9. Base area is 9.12. Then I multiplied by the height, 20.064 feet cubed. Next one, on the front, I've got a triangle. In the back, I got a triangle. So those are my bases. And then my height must be 12. So my base area, since it's a triangle, would be 1/2 of base times height. Base would be 8, height would be 6. So that ends up being 48 times 1/2, which is 24. And then my height is over here. It's the connecting portions to the two triangles. And I get 288 centimeters cubed. On next one, they give me the hypotenuse and one of my legs, but that's not the base and the height. We have to use the parts that are perpendicular for base and height. So this is a 3, 4, 5 triangle, or you could have used the Pythagorean theorem. So the base and the height of that triangle base would be 3 and 4. So 1/2 of 3 times 4, there's the base area. And the height would be these connecting portions between the two triangles that are identical. So we end up with 6 times 6, 36. Number 4, we've got pi r squared times the height of 12. So that's 16 pi times 12, 192 pi centimeters cubed. So that's the exact answer. If we wanted to give a decimal answer, we would just do 192 times pi in our calculator and then round it appropriately. For this one, they gave us the diameter. We need the radius. The radius would be half of that, 9. So we do pi times 9 squared times 20. Comes out to 1,620 pi. Again, if we wanted the decimal answer, we just do 1,620 times pi in our calculator and then get some rounded answer from there. Next one, we use 1/3 pi r squared times the height. So we end up with pi r squared is 9 pi. 9 pi times the height is 81 pi. And then I take 1/3 of it and I get 27 pi. Units are inches cubed. Next one, we were missing the radius, but we had the height and the slant height. So we can use the Pythagorean theorem, or you can remember this is one of your triples. This is an 8, 15, 17 triangle. So you either use the Pythagorean theorem, do r squared plus 15 squared equals 17 squared. Either way, that's 8 for the radius. So we do 1/3 pi times 8 squared times 15, and we get 320 pi meters cubed. Next one, we've got 4/3 pi 3 to the third, not to the second. So 3 to the third is 27. Remember, we multiply by 4, then divide by 3 when we have 4/3. We get 36 pi. For my hemisphere, I use 2/3 pi r cubed, so 6 to the third power, that's 216. We multiply by 2, divide by 3, and we get 144 pi. Number 10, the cylinder and the cone have a relationship. Since they have the same radius and same height, the cone is going to be 1/3 the size of the cylinder. So we would just take the volume of the cylinder and divide by 3, we get 40 pi. Number 11. So for this one, just plug in what you know into the formula. We know the volume, we know the radius, we don't know the height. So I've got 4 squared, that's 16 pi. So I would just divide both sides by 16 pi. The pi's would go away. 160 divided by 16 is 10. For the next one, we'd write out the formula for a cone, and we'd plug in what we know. We know the volume, we know the height, we don't know the radius, so that stays a variable. To clean this up, I divided by 20 on both sides and got 12. To get rid of the 1/3, I multiplied by 3 on both sides and got 36. Then I divided by pi on both sides. I got r squared equals 36. And I took the square root and I got 6. That is all I've got for you. That took a while. It was meant to. We basically did like 4 lessons of a Math 8 lesson in one shot. So hope you enjoyed it. Have fun. Keep mathing hard. Be good. See you later. Bye-bye.